The first thing is the activity that we are going to be doing in class on Thursday. So those are the things that I wanted to mail out if possible. It looks like this. It's a big piece of paper. If you're going to be face-to-face with me tomorrow, you'll get this. We're going to use it Thursday. It's a big sheet, but the important part is that we have this 10 by 12 inch rectangle you have to cut out, and then you have to cut corners out of each corner, I guess, and then you make a box that doesn't have a top by folding flaps up, and that's part of your notes for tomorrow night. So you definitely need to have that in your hands by tomorrow. So if you're all virtual, we need to get that to you because I only mailed one out. It's the only request I got. So we got to get that in your hands by having somebody pick it up or putting it at the front desk for you. Okay. The next thing I handed out is the rest of the notes for the rest of the semester. Today's notes are starting on day 13. So you all should have that. That's not part of the note packet. I handed that out before break. Just an announcement about the rest of the semester. We're going to have a Unit 5 exam on 14th of January. That's a Thursday. And then we're going to go right into Unit 6. So we're not going to have a cumulative final. We're just going to keep moving along with the material. Unit 6 will be second semester. Okay, so as you're going into exam, we don't worry about taking an exam for calculus. It's not going to happen. Yeah, so just didn't know what a cumulative would look like. I mean, probably would look like what we've been doing all year, but still. Okay, so I will repeat those tomorrow for those people who are face-to-face tomorrow so that you can see all my fun hand gestures or whatever. But it'll happen. Okay, so we had notes for today. I hope you did them, but you might be able to roll with it if you didn't, so don't get too freaked out. So the idea is that we've kind of got the nuts and bolts here. We've got a first derivative test, a second derivative test. We're talking about extrema, mins and maxes, cusps and corners. We're talking about points of inflection and concavity, and we need to start knowing what those look like on the first and the second derivative graphs. Okay, so if your function has a max, what does that look like if you have a graph of the derivative, not the actual function? Okay, so that's what those were about. We connected mins and maxes. Excuse me, a little cough there. We connected mins and maxes on the function. I'm trying to get my cursor to behave here. There we go. Mins and maxes on the function with 0 values on the derivative. So think about having a 0, right? It crosses the x-axis. If you have a graph of the derivative, that's where your mins and maxes of your function are going to be, is where you cross the axis. We want to connect increasing functions with positive slope values. So if we look at the derivative, we know our function's increasing when our graph of our derivative is either in quadrants 1 or 2, right? Those are all the positive values. A function is decreasing when we have negative derivative values. So if we look at the derivative, we'd be in quadrants 3 and 4. So it's learning to connect those sort of characteristics. Connecting concavity with increasing slopes or increasing derivatives, or concave up, and decreasing slopes or decreasing derivatives with concave down. So what does that mean? Well, if my slopes are increasing in value, that means my second derivative is positive. Okay, so same sort of thing. Second derivative of positive would be if I had f double prime, a graph of that, I'd be up in quadrants 1 or 2. Second derivative negative, if I had a graph of f double prime, it would be down in 3 and 4. And then points of inflection are extreme values. So points of inflection are kind of special because if we have a graph of the first derivative, an extreme value would be a max or a min. There's where our points of our points of inflection are located. If I have a graph on the second derivative, it's located at the x-axis again, where we cross from positive to negative or negative to positive. Okay, so it's making those connections graphically. Okay, so summarizing as far as connecting and justifying features across all three of these graphs, we're going to rely on the justifying graph features organizational table that was part of your notes. Going to keep referring back to that organizational table. Okay. And then we're going to look at, today we're going to look at the topic questions. Tonight there's no notes. Tomorrow we're just going to do an activity, a matching activity in, what did I make that activity? I think I made it in Desmos. Matching activity in Desmos, matching the function and its first and the second derivatives, matching all those up. Okay, so you can go ahead and open up the topic questions in your College Board account. Topic questions day 13, and you should have some space on your note packet to generate solutions to those questions, and then you can take a look at the answers and definitely spend some time taking a look at the wrong answers too, to address those misconceptions and address those teasers. Any questions? Okay. I'm going to let you go ahead and do that. I'm going to stop the recording. But obviously the session is going to continue to be live. Stop there.